about was a 30, 60, 90 triangle. And the original setup in our notes, and I don't necessarily want to rederive it, but we were talking about an equilateral triangle, so all sides the same, with a side of 2. And then we dropped a perpendicular, so that cut our other side in half, and that was a 1. Do you guys remember this scenario in our notes? We did, like, if I take an equilateral triangle, and then trig functions only work in a right triangle, so to make this right, we dropped the perpendicular, so then this base side was just 1. And then we did Pythagorean theorem, and we got the other side to be radical 3 when we did this in our notes. And so in that triangle, my 3 angles are 30, 60, and 90. And then the sides, the side opposite the 30 had a length of 1, the side opposite the 60 had a length of radical 3, and the side opposite the 90 had a length of 2. The second triangle we looked at was an isosceles triangle. So isosceles means 2 sides are the same, and these angles would then have to be the same. So these were both 45. And we did an isosceles triangle with side lengths of 1. So those were both 1. And then Pythagorean theorem, 1 squared plus 1 squared equals c squared. So this third side was the square root of 2 when we did it before. So in this triangle, our angles were 45, 45, and 90. And the sides were 1, 1, and square root of 2. So these were the beginning special triangles that we had. Now what I want to do is take these and adjust them so that the hypotenuse is 1. Okay, we know that similar triangles, the angles don't change and the sides are proportional. So if I'm still looking at the 30, 60, 90 triangle, my angles won't change. If I want to change the hypotenuse to be 1, what do I have to do to the original hypotenuse to turn that into a 1? We divide by 2. So to get the other sides, we'll also divide those by 2. So this side becomes 1/2. This side becomes radical 3 over 2. So let's do the same thing in our 45, 45, 90 triangle. So originally, my hypotenuse was the square root of 2. If I want that to be 1, we have to divide by the square root of 2. So this side becomes 1 over the square root of 2, which is the same as square root of 2 over 2. All right. So what we're going to talk about now, the unit circle is a circle with a radius of 1. And we already touched on it when we did our degrees and angles the other day. So the center is at 0, 0 on the xy axis, and the radius is 1 for the unit circle. So when I'm looking at these special triangles, the radius is the distance from the center out to the edge, and that length is 1 on all of those because it's the radius. And then if you look at your special right triangle, that radius was 1. What was the side opposite the 30-degree angle? Look at that little table we just filled out. When the hypotenuse is 1, the side opposite the 30 was 1/2. Okay, this would have been a 60-degree angle, so the side opposite 60 was radical 3/2. So if you're trying to talk about the point on the circle, you go over radical 3/2, up 1/2. So this point right here on my circle is radical 3/2, 1/2. All right, now these sides are the same in the other triangles, except in this triangle, if you're plotting a point on the x-axis and you go backwards, we know that is negative. So the side is negative radical 3/2. And the side is still a positive 1/2. So my ordered pair, to get to this point on the circle, we go back negative 3/2, up 1/2. What happens in my next triangle? What are both of those sides? Positives or negatives? Negative. So it's negative radical 3/2, and then we go down 1/2. So the point on the circle is negative radical 3/2, negative 1/2. Okay, in the fourth quadrant, your x is positive because we're moving to the right, but the y is negative because we're going down. So the point on the circle is radical 3/2, negative 1/2. All right, so what I just found are 4 points on my unit circle, and they all relate to those special right triangles that we've already seen. Are you guys okay with me there? So let's go to the 45. So the radius is still 1. So all of these lengths are still 1. Okay, in the 45, 45, 90 triangle, look at the table we did when the hypotenuse is 1. What were these sides? Okay. In the first quadrant, they're both positive. They were the same, so to get to the point on the circle, you go over radical 2/2 and up radical 2/2. In the second quadrant, we have to back up. So this would be a negative. And then we go up. So that's a positive. So the point on my circle is negative radical 2/2, positive radical 2/2. All right, in the third quadrant, we have to go over and down. So both of these are negative. So the point on my circle is negative radical 2/2, negative radical 2/2. On the fourth quadrant, we're moving to the right, so this side is positive, but then we go down, so this side is negative. So we get positive radical 2/2 and negative radical 2/2. You guys see where I'm getting all these numbers? All right, last one. So in this 60, my radius is still 1. So in our special right triangle, the side opposite the 60 was radical 3/2. My other side was 1/2. So at this point we go over a half and up radical 3 over 2. The second quadrant, we're backing up a half, so this is a negative. We're still going up, so we get negative 1/2 radical 3 over 2. In the third quadrant, we are going left and down, so both are negative. So negative 1/2 negative radical 3 over 2. And in the fourth, we go over, so that's positive, but then down is negative. So we get 1/2 negative radical 3 over 2. So all of these ordered pairs are related to our special right triangles. So now, we are going to put it all together to make one big unit circle. So we have done part of the unit circle before. We did the degrees and radians already. So let's start by adding those on. Okay, so this was 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Then we drop down to 180. And then in the second quadrant, we do 180 minus the reference angle. So 180 minus 30 is 150. 180 minus 45 is 135. 180 minus 60 is 120. In the third quadrant, we add our reference angle. So 180 plus 30 is 210. 180 plus 45 is 225. 180 plus 60 is 240. And this line down here was the 270. And then for the fourth quadrant, we've said 0 is the same as 360, so you could label it as either. So we do 360 minus. So 360 minus 30 is 330. 360 minus 45 is 315. And 360 minus 60 is 300. Then we did radians. So 0 degrees was 0 radians. What was 30 degrees? Pi over 6. 45 is pi over 4. 60 was pi over 3, and 90 is pi over 2. Okay. 180 is the same as pi. And so we've talked about some of the patterns. We said the reference angles always have the same denominator. So 30 degrees when the reference angle is 30, the denominator is always 6. 45 always has a denominator of 4. 60 always has a denominator of 3. Remember, in the second quadrant, we're essentially subtracting from pi, so the pattern we found was the top was 1 less than the bottom. So 1 less than 6 would be 5, so 5 pi over 6. 1 less than 4 is 3, so 3 pi over 4. 1 less than 3 is 2, so 2 pi over 3. What was the pattern in the third quadrant? Do you remember? 1 over. So my denominators are still 6, 4, 3. 1 higher, so 7 pi over 6. 5 pi over 4. 4 pi over 3. This would be 3 pi over 2. And then the fourth quadrant. 360 is the same as 2 pi, so you could label it as either. What was the pattern in the fourth quadrant? double minus 1. So double 6 would be 12, minus 1 is 11 pi over 6. 4 times 2 minus 1 is 7 pi over 4. 3 times 2 is 6, so 5 pi over 3. Is everybody okay with those numbers and how we've gotten those? So the final thing we are adding to this circle is ordered pairs. Some of the ordered pairs we know. Remember, this is centered at 0, 0. And the radius is 1. So if you start at 0, 0 and you go right 1, this is now the point 1, 0. If you have 0, 0, you don't move left or right and you go up, this would be 0, 1. Start at 0, 0 and go left, so that's -1. We don't go up and down, so -1, 0. And this would be 0, -1. Then these others come from this little picture that we did. So with my pi over 6, that's my 30 degrees. All 4 of these ordered pairs are the same. The only difference was the positives and negatives, right? So they were all radical 3 over 2 and 1/2. But in the second quadrant, the x was negative. In the third quadrant, both x and y are negative. In the fourth quadrant, x is positive and y is negative. All right. So all of my reference angles of 45, my pi over 4s. Look at your picture. All of these were radical 2 over 2 and radical 2 over 2. The only difference was the signs, depending on the quadrant. So, pi over 4 would be radical 2 over 2, radical 2 over 2. 3 pi over 4, the x is negative, so negative radical 2 over 2, positive radical 2 over 2. 5 pi over 4, both x and y are negative. And 7 pi over 4, x is positive, y is negative. So now we look at our 60s. All of these were 1/2 and radical 3 over 2. The only difference is the sign. So in the first quadrant, those are both positive. Second quadrant, the x is negative. Third quadrant, they're both negative. And fourth quadrant, x is positive, y is negative. Okay. Now, I'm going to take this a step further. I want to talk about one more pattern that's with that. Think back to x, y, and r definitions. Okay, we have said before, the very first time we talked about our trig functions, we said that cosine was x over r, and sine was y over r, right? In the unit circle, what is the radius? It's just a 1. Like we said here, in a unit circle, it's centered at 0, 0, and the radius is 1. So if I put in a 1 for my r, that means cosine is my x and sine is my y. So on all these ordered pairs, the x value is cosine and the y value is sine. Think about your hand trick. Sine of 0 is the square root of 0 over 2, which is 0. Cosine of 0, square root of 4 over 2 is 1. At 30, sine square root of 1 over 2 was a half. Cosine square root of 3 over 2. 45, sine and cosine are both radical 2 over 2. At 60, sine was radical 3 over 2, cosine radical 1 over 2, or 1 half. At 90, sine is the square root of 0 over, or sorry, square root of 4 over 2, which is 1. Cosine is the square root of 0 over 2, which is 0. So these are your values of sine and cosine. So if I asked you to find the sine of 330 degrees, you could look right here. 330, sine is y, so the sine of 330 is negative 1 half. Just like we've been doing before, except we were doing quadrants and reference angles. This is essentially everything put in one picture. Degrees, angles, and our values of sine and cosine. Do you guys have any questions? So we are going to work with this more tomorrow. I will give you, like, I'm not expecting you to start homework, but if you wanted to, we could. Because this section is really nothing new. It's a lot of find the sine of 7 pi over 6. And you would write down that's quadrant 3, reference angle 30, and you could evaluate it. You are welcome to start. You do not have to. So tomorrow, we're going to practice the unit circle again, talk more about where these values come from, how we might use it, and do examples. Okay. But if you wanted a jump start, you're welcome to do that.